Sentinel satellite. What is Sentinel? Sentinel is a fleet of satellites designed specifically to deliver the wealth of data and imagery that are central to the European Commission's Copernicus program. They are equipped with various sensors and instruments that allow them to monitor the Earth's land, oceans, and atmosphere with high resolution and coverage. There are multiple types of Sentinel satellites, which is Sentinel-1, Sentinel-2, Sentinel-3, and Sentinel-5P. Slide show the observation image used by Sentinel-2. On the left side, there are sea surface topography of Kuala Perlis area that was taken with Sentinel-2A. And on the right side, the first image delivered over the Baltic Sea in the northern Libya area was taken with Sentinel-2B.
Assalamualaikum, my name is Nur Syasha Izzati binti Azlan and I will continue with the specification of Sentinel. The first is about the sensor complement and power is the same, which is a CSAR, stand for the C-band synthetic aperture radar. Second is about the orbit type. Using the type of the orbit is SSO, Sun Synchronous Orbit in 12 days and repeat cycle in 80 hours. Orbit latitude is 693 km.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syazliana binti Muhammad Azmi and I'm going to present about Marine Observation Satellite MOS. Marine Observation Satellite 1, MOS-1, is the first Japan's Marine Observation Satellite, also known as MOMO-1, was launched on February 19, 1987. Operated by the National Space Development Agency of Japan, NASA, and Japan Aerospace Exploration Agency, JAXA. MOS-1 provided valuable marine data until its end of life on November 29, 1995. A second satellite, MOMO-1B, MOS-1B, with the same function, launched on February 7, 1990, and concluded operations on April 17, 1996. These satellites marked significant advancement in Japan's marine observation capabilities. Next, we are going to talk about characteristic type of sensor of MOS-1 and MOS-1B. MOS-1 and MOS-1B were equipped with advanced sensors for diverse environmental monitoring. First, the multispectral electronic scanning radiometer (MESSR) covered 4 bands with a 50-meter resolution and a 200 km swath, absorbing ice distribution, land use, snow cover, and ocean chlorophyll. Next, the visible and thermal infrared radiometer (VTIR) spanned 6 bands with a resolution of 0.9 km until 2.7 km and a 1,500 km swath, monitoring snow, clouds, ice coverage, and sea surface temperature. We also have the microwave scanning radiometer (MSR) with a 23 until 32 km resolution and a 317 km swath, assessing atmospheric water vapor, snowfall, and rainfall. Then we have these pictures of observation image. These pictures represent satellite image that had been captured. The first one is by MOS-1 by using MESSR captured an ice flow of the Sea of Okhotsk, and MOS-1 using VTR captured distribution of the sea surface water temperature.
Introduction to mangrove observation. Mangrove observation is a process of the systematically observing and evaluating mangrove ecosystem through a variety of the techniques such as ecology research, field survey, and remote sensing. The help size and also dynamic of mangrove forest, essential coastal ecosystem that provide a variety of ecological service like carbon storage, coastal protection and habitat for the wide range of the species. Researchers can now collect the high resolution data to monitor changes in the mangrove cover, evaluate the effect of the climate change, and direct conservation effect through the deployment of sophisticated satellite technology and also GIS tool. For the sustainable management, well-informed decision making, and the preservation of this important ecosystem, effective mangrove conservation is crucial. The importance of the mangrove observation first is a tracking ecosystem. Tracking the health of the ecosystem by measuring forest extent and tree height is critical to informing sustainable management of the mangrove and the service provided. Second is a research. The research can detect the presence of the mangrove and to measure their size and shape, and also use a new technology allow research to track the high and carbon content of the mangrove canopies. The last is important is the climate regulation. Mangrove adapt to the changing environmental condition, can gain a sign into the ecosystem, design and inform the climate adaptation strategy. Issue arising of mangrove conservation. The first issue is about the pollution and deforestation. Mangrove ecosystems are under the constant threat from the human activity such as agriculture and urbanization. The second issue is about climate changes. Sea level rise is the biggest climate-related threat, with some tree species unable to tolerate the salt water and escape the surging tide. Mangrove forests absorb a significant amount of the greenhouse gas emission. The third issue is site selection. The site need to have a right environmental condition to support mangrove, including the soil type, water flow, and level of salinity. Impact toward the issue. From the issue deforestation and human activity such as agriculture and urbanization, this activity can cause damage to mangrove forests and make the restoration effort more difficult. Issue climate changes can give the impact which higher temperature can cause psychological stress in mangrove species, affecting their growth, reproduction and also survival rate. The last impact mangrove as an organic barrier against erosion from the coast and storm surges. Mangrove are essential to the survival and reproduction of the many species. Biodiversity might decrease as an effect of the habitat loss.
Important parameters. There are 4 important parameters that we mentioned in this slide. For the first one is Leaf Area Index or LAI. Leaf Area Index is a dimensionless quantity that characterizes the amount of leaf area in a plant canopy. It is defined as the total leaf area per unit ground surface area. Changes in LAI can signal alterations in mangrove health due to environmental stressors like salinity changes, pollution, or deforestation. Second is a Normalized Different Vegetation Index or NDVI. Normalized Different Vegetation Index is a widely used remote sensing index that quantifies vegetation health and density. It is calculated using the reflectant values in the red and near-infrared spectral bands, which are sensitive to the presence and condition of green vegetation. Healthy mangrove typically have higher NDVI values. In the right side is a formula of NDVI. Thirdly is a Soil Adjusted Vegetation Index or SAVI. SAVI is functioned to reduce the influence of soil brightness in area where vegetation cover is low. This makes it especially valuable in situations where soil background noise may obscure vegetation signal, for example, in areas where vegetation cover is low or plants are young. It offers improved accuracy over NDVI by reducing soil background noise for better assessment of vegetation health and density. 4 is a chlorophyll content. It's a critical indicator of plant health and photosynthetic activity. Chlorophyll is a vital for photosynthesis, and its levels can reflect changes in environmental conditions, nutrient availability, and stress factor. Low chlorophyll levels can signal stress or poor health of mangrove tree. Next, methods to solve the issues. The first one is a vegetation indices. It employs indices like soil adjusted vegetation index (SAVI), normalized different vegetation index (NDVI), or leaf area index (LAI) to assess mangrove cover and health, as it is a widely used and effective index. Second is a classification techniques. It uses machine learning algorithm like random trees, support vector machines, or deep learning models to classify mangrove species and estimate biophysical parameters. And the third one is mixed pixels and spatial resolution. It utilizes high-resolution spectral data from sensors like Landsat, Sentinel, and Worldview to capture detailed spectral signature of mangrove cover. Next, gaps for a further study. In this slide, there are two gaps for a further study. The first one is impact of environmental stressor. Gap challenge is to identifying and quantifying the impact of environmental stressors such as pollution, climate change, and human activities on mangrove. For the further study is to create algorithms that can detect and quantify stress indicators from remote sensing data. Next is the temporal resolution and tidal influence. The gap challenge is temporal changes due to tides and seasonal variations can complicate the interpretation of mangrove dynamics. And the further study is to create tidal correction model, which is develop more accurate models to correct for tidal influence in remote sensing data.
Hi, it's me again. Now I will talk about the problem statement based on mangrove observation. Approximately one-third of the world's mangrove forests have disappeared over the last 50 years, while the majority of data show very varying rates of loss and most estimates have a large range of error. The mangrove forest, vital ecosystem teeming with life, face an array of threats that imperil their existence. Rapid deforestation driven by urbanization, aquaculture, and agriculture is raising these verdant heavens, leading to alarming biodiversity loss. Pollution from various sources further deteriorates the delicate balance, harming both flora and fauna. Climate change exacerbates the crisis with rising sea levels and intensified storms wreaking havoc on mangrove health and distribution. Next, overexploitation of resources compounds the issue, depleting habitat and impacting local livelihood. Adding to the woes are innovative species, outcompeting native mangrove and disrupting ecosystems. Urgent action is needed to address these multi-phase challenges and ensure the preservation of this invaluable ecosystem. So how are we going to solve the problem statement? So this is some of suggestions to solve the problem statement using satellite application. First is monitoring deforestation. Satellites can provide high-resolution image to monitor changes in mangrove forest cover over time, allowing for the early detection of deforestation and illegal logging activities. Second, tracking pollution. Satellites can also detect pollutants in water bodies surrounding mangrove areas. By monitoring water quality parameters such as turbidity, chlorophyll, and chemical concentrations, authorities can identify pollution sources and assess their impact. The last one is mapping and managing invasive species, which is satellite imagery can help identify and map the spread of invasive species in mangrove forests. This information can guide targeted removal efforts and prevent further spread. That's all from all of us. Thank you for watching and listening. See you again. Bye bye.